Hi friends, Susen Tycoon once again, and today I brought you the simplest way you can use to understand the concept of the critical angle and the total internal reflection. After watching this video, I can assure you will be able to explain this concept very clearly. For the formation of critical angle and the total internal reflection, there should be under one necessary circumstance, that is, the ray of light should come from the optically more dense medium to an optically less dense medium, for example, from water to air or from glass to air. Basically, you have to know that when the light travels from one medium to another medium, it will get bent, and this is what is called the reflection of light. Now let's consider this illustration here. Here we have air medium and water medium. And it's obvious that water medium is optically more dense than air medium. Hence, when the light travels at a small angle of incidence, it's matter of fact that there is a strong refracted ray and a weak reflected ray. Since not all the light will be refracted, but some small amount of light will be reflected at the angle equals to the angle of incidence, and this obeys the law of reflection, which states that the angle of incidence equals to the angle of reflection. I think you have understood. As the angle of incidence increases, also the angle of refraction increases. Now let's see here. The angle of incidence increase. Let's call this ray B. This should be ray 2. Since this is the ray 1, the ray of light will be refracted at a certain angle. Now, as I've said, as the angle of incidence increases, also the angle of refraction increases. And this, there is some light will be reflected. That is this B1, this should be B0, this B2. Now, as the angle of refraction increases, the refracted ray now become weak than the reflected ray within a more dense medium. This is because it becomes more likely for the light to be reflected than to be refracted due to the increase in angle of incidence. Now at a certain angle, let's call this C1. At a certain angle, we're gonna find that the ray of light is now reflected parallel to the boundary between two media to form 90 degrees, and at the corresponding angle of incidence is called the critical angle. Now we can define the critical angle as the unique angle of incidence for which the angle of refraction is 90 degrees. Understood? What is critical angle? I think you have understood. And if the critical angle exceeds, we will find that all the light will be reflected internally within the more dense medium. This only if when the angle of incidence exceeds the critical angle. Now, after all the light being reflected internally, we can say the total internal reflection has just occurred, and at this stage there is no refraction at all. Now we can define the total internal reflection as the reflection occur when the angle of incidence exceeding the critical angle. I think you are now conversant with the topic. Now, I have a question to you. Can we use the critical angle to determine the refractive index of a material? Absolutely yes. Let me show you how we can use the critical angle to determine the refractive index of a material. The refractive index of a material equals to sine of angle of incidence over sine of angle of refraction. This is only when the light comes from less dense medium to the more dense medium. For example, from air to glass or from air to water. But since it is total internal reflection, here the ray of light is coming from more dense medium to the less dense medium, and this formula should be reversed. Therefore, the refractive index of a material will be sine of angle of refraction over sine of angle of incidence. Now the refractive index equals to, but you have to remember that the angle of refraction equals to 90 degrees as seen here, and the incidence angle equals to critical angle. Therefore, the refractive index of a material will be sine of 90 degrees over sine of critical angle. But sine of 90 degrees equals to 1. Now the refractive index of a material will be 1 over sine of critical angle. This is the formula, and this is true for all the material media.